Hello, and today's learning target is I can solve a system of equations by substitution. So, to review, remember that a system of equations is two equations and we want to find the point where they intersect, if possible. The answer to these types of problems will be an ordered pair. So we'll get a solution for most of the ones that we are solving, but remember, it could be the same line, so we could have infinitely many solutions, or the two lines could be parallel, so they would never intersect, meaning that there is no solution. But we're going to work on solving the following systems of equations using the substitution method. So let's take a look at the first example. I see y equals 2x plus 1 and 3x plus y equals negative 9. What I want to do with substitution is I want to substitute in an expression in for another variable to replace that variable. So we only have to work with one instead of two, which means I see both a y and x, but I only want to deal with one at a time. It makes everything a lot easier. So I'm going to circle what y equals, and y equals 2x plus 1. And when I go into my second equation, where I see y, I'm going to substitute that expression in for y, because y and 2x plus 1 mean the same thing. If they equal each other, if we put them on like a balance, to balance weight, they would weigh the same. They'd be the same thing, right? They equal each other. So I'm going to substitute that in for y, and so what I have is 3x plus 2x plus 1, so I've inserted that expression in for y, equals negative 9. Now I'll solve, so I'll put together 3x plus 2x and get 5x plus 1 equals negative 9. Solve for x, and 5x equals negative 10, so I'll divide by 5. So here x equals negative 2. But that's only half of my solution. I need to find the other half. I need to find an ordered pair, which means a y value. So I'm going to substitute this x equals negative 2 back into an equation, either one, the first here or the second, and solve for y. Whichever one would be easier to plug in for, I would do. And that would be, the first equation would be much easier to plug in y for. And just because y equals 2 times whatever x is plus 1, right? So I'll say here y equals y equals positive 2 times negative 2 plus 1. Negative 2 times 2 is negative 4 plus 1, so y equals negative 3. So as an ordered pair, my final answer would be negative 2, negative 3. And so if I were to plug that ordered pair back into both equations that I just used to solve, it would be a solution for both of them because it would work for the system of equations, so for both of them. So that would be my final answer written as an ordered pair. Let's take a look at the next example. All right, let's take a look at the next example. So I see y equals negative 4x plus 12, and I'll substitute that in where I see y in the second equation. So I have 2x plus negative 4x plus 12 equals 2. And 2x plus negative 4x is negative 2x plus 12 equals 2. Subtract 12 from both sides. Negative 2x equals negative 10. Divide by negative 2, so x equals 5. Now I'll take that answer and I'll plug it back in either equation. And I usually like to pick the easier of the two equations, which would be this first one. So I have y equals negative 4 times 5 plus 12. And negative 4 times 5 is negative 20. Plus 12 is negative 8. So my final answer, written as an ordered pair, would be 5 comma negative 8. And again, I could plug that back into both equations to make sure that it satisfies them. So I'll go ahead and do that right now just to show you that it will work. All right, so I'll take the first equation, negative 8 equals negative 4 times 5 plus 12. And so does negative 8 equal negative 20 plus 12? It should if this ordered pair works out, and it does, so yes. Now if I plug in the other the ordered pair into the other equation, I have 2 times 5 minus 8 equals 2. 2 times 5 is 10 minus 8. Does that equal 2? It does. So it works. It's a match for both equations. So that would be the ordered pair. That would be a solution to this system of equations. Okay, let's take a look at another example. I'm going to substitute in the 4x minus 6 in for the second equation where I see y. Again, I'm replacing y with that expression so that I only have to worry about the x's. And here, since I have 3 times y, I have to do 3 parentheses because I'll have to distribute that 3 to each term that I'm substituting in y for. And so I'll distribute that and get 5x plus 12x minus 18 equals negative 1. 5 plus 12 is 17x minus 18 equals negative 1. Add 18 to the other side. Get 17x equals 17. So x equals 1. Now I'll plug that in. Again, it's always good to pick the easier equation, but it really does not matter. You'll get the same answer. So I'll pick, excuse me, that first equation and get y equals 4 times 1 minus 6. So y equals 4 minus 6. Y equals negative 2. So my answer here is 1 comma negative 2. That would be a solution to both of these equations for this system of equations. Okay, let's continue. The final example here. So y equals x minus 2 will get substituted in for y above. So I have 3x minus, here I will plug in x minus 2 equals 6. And this is really a negative 1 right there, so that I'll have to distribute. So I'll distribute that right now and get 3x minus x plus 2 equals 6. And 3x minus x is 2x plus 2 equals 6. Subtract 2 and get 2x equals 4. Divide by 2, so x equals 2. Now I'll go ahead and plug 2 back into the easier equation, so the second one here, and get y equals 2 minus 2, so y equals 0. So my answer would be 2 comma 0. Now for all of these examples, we substituted in the expression that y equaled into the opposite equation where we saw y, but we could have easily done this if we had x equals an expression and substituted that expression in for the opposite value x as well. So it would have worked with both variables. Thanks for listening. Have a great day. Bye-bye.